Okay, example 4. A chemical is packed into bags by a machine. The mean weight of the bags is controlled by the machine operator, but the standard deviation is fixed at 0.96 kilograms. The mean weight should be 50 kilos, but it is suspected the machine has been set to give underweight bags. So there's a difference in this particular question. We're looking at a less than. If a random sample of 36 bags has a total weight of 1,789.2 kilograms, is there evidence to support the suspicion? You must state the null and alternative hypotheses, and you may assume that the weights of the bags are normally distributed. Okay, so let's define our random variable. So let W be the random variable, the weight of a randomly selected bag. With that, then the parent population is normally distributed, and the mean weight should be 50 kilos, and the standard deviation is fixed at 0.96. The sample means, so W bar is also going to be normally distributed. It will have the same mean, but its standard deviation is 36 bags. So that's the variance, meaning the standard deviation is 0.96 over the square root of 36, which is 6, and so on. So that's my parent normal distribution, that's my sample population of means. We then want our calculated sample mean. Which isn't given to us, but we do know that the total weight of the 36 bags is 1789.2. So if I divide that by 36, um, 1789.2 divided by 36 is 49.7, and that's W bar. Okay, so that's all the information about the distributions. Now we want to form our hypotheses. So our null hypothesis is going to have an unchanged mean, so that's going to have a mean of 50, and in the context of this, that means no fall in the mean weight of the bags. Then the alternative hypothesis in this case is underweight bags, so that the mean will be reduced. It's a one-tailed test, and in this instance it doesn't give us a significance level. So this is an example where I couldn't use method 2 with the critical regions. Okay, so can't find So our p-value then we've got a mean of 50. We're interested in what this region here is that will have a probability, an area less than the calculated sample mean, which is 49.7. So what is the probability that the mean weight is less than 49.7? So normal cumulative, lower in this case because we're at the bottom end, is going to be minus 1 times 10. No, it's not. It's going to be 1 times 10 to the minus 99. The upper is 49.7. The standard deviation is 0.96 over 6, which is that, and the mean is 50, giving us a p-value of 0.03. So if we were working at a 1% significance level, the p-value would be greater than it. So therefore the null hypothesis would be accepted. If we were operating at a 5% significance level, then that p-value is within that level of significance. So the conclusion that you could draw from that would be that there is a limited amount of evidence to suggest because it's between the 1% and the 5% level of significance. And you might then want to put forward an additional larger sample could be selected. More often than not, they're going to tell you what that significance level is, but if they don't, then it's forcing you to use that p-value and measuring the strength relative to a 1% and a 5% significance level.